So I'm doing a selected part of the try nows 25. I'll do try now 25. In your textbook, you should be able to check if you have the textbook. Otherwise, you just follow the instruction as I give it here. The try now 25. I'll do question 26. I'll also look at try now 27 and then also try now 28. These ones I'm going to do them together. Then perhaps if you have the textbook, or you can try then the others yourself to see. Okay, right. So let's start with this one. So the thing here is there is something here that you need to be on the lookout for, and that is this term here. There is going to be the product that we are going to apply, the product rule. So we are going to apply the product rule. Very important that you understand that. So dy dx, or let's rather say d by dx rather, of 2x squared plus 6xy plus y squared is equal to d by dx of 9. Okay, right, so let's take the constant term by term. That is going to be 4x. Here I'm going to introduce brackets because I'm going to apply the product rule, which says that take 6x as we are going to treat 6x as a function, and we are going to treat y as a function on its own. Now I could have dragged out the 6 as a constant multiplier, but I don't want to have to multiply over by that 6 again, so I'm just going to keep the 6xy. So 6x being the first, so you keep the first, multiply by the derivative of the second, which is just 1. Then you don't forget, you must attach dy dx because you did the derivative of y, plus the second term y times the derivative of 6x, which is just 6. Okay, plus now I'm going to be at the y, the one here. So the derivative of y squared, that is 2y, and don't forget to attach dy dx because y is a function of x, and the derivative of a constant is 0. Okay, so let's just clean up the stuff here. So I'm going to have 4x plus 6x dy dx plus 6y plus 2y dy dx is equal to 0. Okay, so my terms that have got my dy dx is the 6x here and the 2y here, which is the terms that I'm going to sort of group together. Okay, but I can just go as well take out and just write it as 6x plus 2y and have my dy dx over here, and everything else moves to the other side of the equal sign, becomes minus 4x, and that 6y becomes minus 6y. So at the end of the day, we just have to do the divide throughout by 6x plus 2y, so therefore dy dx is equal to negative 4x minus 6y all over 6x plus 2y. And there you go. You have done that one. Okay, let's go to the next one. So what we have here, we have the natural log of xy is equal to 4 minus y squared. So you must just be a bit careful when you are doing this one here. You have that product in there in between. I hope you can understand that. All right, so you have the natural log of that product, and then so there is going to be the product rule that I'm going to apply as well. Okay, now let's start with it. So this is um, d by dx of the natural log of xy equals to d by dx of 4 minus y squared. Okay, hope we are together so far. Then if you remember the natural log, how do you take the derivative of a natural log? So if you have d by dx, let's just do the general. then the derivative is that f of x comes under, and on top you have the derivative of that. So in this particular case, I'm going to have 1 over xy, then I'm going to multiply with the derivative of xy. Now, here's the thing. If I multiply with the derivative of xy, I need to apply the chain rule there. Okay, so that means keep the first times the derivative of the second, dy dx, plus the second times the derivative of the first. Okay, and this should equal to, well, the derivative of 4 is just 0, and minus 2y, and then attach dy dx. Okay, so we can just as well clean up the bracket. Now remember, everything here should multiply with everything inside the bracket, so let's just keep it first. X 1 over x is going to be x dy dx plus y, okay, is equal to negative 2y dy dx. Okay, so let's multiply out the first one here, so we can isolate our dy dx. So that is going to be x over xy, that's numerator times numerator, and denominator times denominator, and plus y over xy is equal to negative 2y dy dx. So basically what I'm doing is I'm multiplying this by that and also that by that. Okay, so please don't make any mistakes. Mistakes can be costly. In this case, the x's, they cancel, leaving me with 1 over y, that is dy dx, and here the y's cancel, leaving me with 1 over x, which equals to minus 2y dy dx. Right, so let's get all our dy dx terms to one side. So basically I'm going to take this minus 2y and I'm going to add it. So I've got 1 over y dy dx plus 2y dy dx is equal to, take that 1 over, it becomes negative 1 over x. Okay, now we can actually clean up now. Okay, the calculus is done, it's just the algebra that is there. So this is 1 over y plus 2y, okay, then you have dy dx is equal to negative 1 upon x. So I'm going to continue to the next. Maybe I should append the page. I didn't anticipate that I'll need an extra page. So let's continue with that extra page. So I have just to clear, okay, before I start dividing throughout by that, you know, this can be written as one as a fraction, a common denominator of y. Then I have 1 that is going to be plus 2y squared, and the reason I'm doing that, as you will see in a bit, because we are going to multiply or divide by that number. Okay, right, so let us just then sort of have isolate our dy dx. So dy dx is negative 1 over x. Well, I'm going to keep that one in bracket, times the reciprocal of this one, which is y, over 1 plus 2y squared. Good. Numerator times numerator, denominator times denominator time. Okay, so you're going to have negative y upon, let's just keep that x here and have 1 plus 2y squared there as a bracket. Of course, I can actually leave it like that. So this is dy dx. Okay, you know, there are no common factors, there's nothing, so I can just as well leave it like that. So don't need for me to multiply out that fraction. Good, that is the derivative of that. So please take note, there's quite a number of things that you have to connect, and you just have to be a bit careful when you are applying your rules. Okay, there is one more, I believe, under this series, or two more. So what I have over here is try now 27. I decided to do the A part, which has got some trigging. Okay, so again, don't forget how to do the derivative of three functions. So this is d by dx of x squared sine y. These are two functions, so the product rule will be applied, plus cos of 3y. Then they should equal to d by dx of 4. Okay, now if you do the first one here, you are going to apply, as I was saying, you're going to apply the product rule. So I have d by dx of x squared sine y, and I'm just doing it like that so that I do not make an error. Okay, there's no need to write all of this, but I just find it to work in my favor if I can see those complex ones where the product rule or the quotient rule is used, so I do not end up making mistakes. Right, so keep the first, that's x squared, multiply by the derivative of the second one, that is just the cosine of y, and that was dy dx, because you have got out y in terms of x, then plus, so you're going to have the second, which is sine y, times the derivative of the first, which is just 2x. Okay, plus now we have the derivative of cos, which is minus sine 3y times the derivative of the inside, which is 3, and is equal to 0. Okay, then there is something missing here. Just before I take that 3, of course, you know, so we have got the derivative of cosine is minus sine y, but that is respect to y to x, so you have to say dy dx. See how easy it is to make a mistake. Obviously multiply by 3, which is the derivative of 3y, and that should equal to 0. Okay, so let's just clean up. So I've got x squared cos of y, then I have dy dx here, and then perhaps I can bring this one. This one is minus 3 sine of 3y, and I have dy dx. Okay, and that should equal to, take away that 2, it's going to be minus 2x sine of 2x, because this not sine of 2x, my goodness gracious, it is sine of y. Right, there's no harm in maybe putting these angles in brackets so that you obviously do not make too obvious mistakes. Very, very possible to make a mistake with this. Common factor time, you have, or take out the coefficients, so that is x squared cos y minus 3 sine 3y. Okay, this is all in front of dy dx is equal to minus 2x the sine of angle y. Right, so the only thing left for us to do is just to divide everything that is in front of dy dx over. So you're going to say dy dx is therefore equal to minus 2x sine of y. That should be divided by x squared cos of y minus 3 sine of 3y. And I believe that is your derivative, and you are then done as far as this one is concerned. Now, if it's a bit too fast for you, remember you can always pause the video and you can go back and see. Just be careful with your steps whenever you're dealing with that. Okay, so in this particular instance, you had to apply the product rule here, and here you will be doing something about a chain rule whenever you find the derivative of cos 3y. Right, we have got one more, and this one deals with exponentials. Okay, good. And also you will see that there are some where you will probably have to use the chain rule as well. So I'll just pause and then you can attempt to see if you can solve this on your own. Okay, if you had a go, let's see if our answers are matching. So I have d by dx of 4x. I'm going to separate it, plus d by dx of, I'm not going to take out the 3 because again I do not want to go and have to multiply over that again by that 3, plus d by dx of y squared equals to d by dx of 10. Okay, just find it easier to do it in those parts. The derivative of 4x is just 4. The derivative of here now, here, you have to be careful. You have two functions. Okay, you have this 3y as a function, and you can treat this other one as a function. So I'm going to have to use here the product rule. Okay, so I'm going to bring my bracket in. What does it say? Keep the first, multiply by the derivative of second. The derivative of second is e raised to the power of 2x times 2, okay, plus the second, e raised to the power of 2x times the derivative of the first, which is just going to be 3, and then that is one is dy dx because there is a y involved there. Okay, so that's where I am with that one there. So just make sure that you are on the right path as far as I'm going. Right, I just want to see something. So that takes care of the e stuff in there. Okay, take care of the e stuff. So the derivative of 3y is just going to be 3. Okay, now this is then plus the derivative of y squared, that is 2y, then I have dy dx is equal to 0, derivative of 10. Okay, I have thought that I'm going to run out of space there. So let's just clean up the stuff inside the bracket here. So I have got 3 times 2, that is 6y e raised to the power of 2x, plus this is 3 e raised to the power of 2x. Then I have dy dx here. I don't know why I'm putting brackets there, but let's just continue with the bracket is equal to 0. Okay, right, so where does that leave me? Well, I'm going to have to remove these brackets because I have added them. So 4 plus 6y e raised to the power of 2x, okay, plus 3e raised to the power of 2x dy dx plus 2y dy dx is equal to 0. So that 3e plus 2y, 3 to that, and this is going to be obviously something that I'm going to write on their own. Just change the color. Comes a little bit too unfriendly. Trying to mix it all along. So we have got 3e to the 2x plus 2y. Obviously this one has got dy dx to it. And then we're going to move everything over the equal sign. That 4 is going to be negative, and let's see what else. And the 6y is going to also be negative 6y e raised to the 2x power. Okay, so what is left is just for us to divide throughout by that 3e plus 2y, that coefficient of dy dx, so to speak. So you have got dy dx is equal to negative 4 minus 6y e to the 2x all over 3 e to the 2x plus 2y. And that is it, ladies and gentlemen. That is the derivative of that function. Okay, now I know there's a lot in there So you just have to do things step by step and don't confuse yourselves as you find the derivative, especially when the product rule is involved. Right, so